Now let's study about diffraction in a single slit. Okay. So we'll take a single slit and we'll see how light ray bends and how we get the maximum and minimum. Okay. Let's study this now. So for this, let's see an experiment here. So we'll take a point source of light. Okay. The source of light we write as S. So light from this point source will go in all directions like this way. Okay. Light goes in all the directions. Here what we do is we take a lens. Okay. We keep a convex lens here. We adjust it in such a way that the source S is at the focus of this lens. Okay. Let's mark this lens as L1, the convex lens 1. So this light ray goes through optic center, it goes straight through. There is no deviation. The second light ray, if you see, okay, because it's at the focus, the light ray will be made parallel to the principal axis. So light ray, if you see, it's parallel to the principal axis like this way. Okay. So at this point, what we do, we keep a slit here. Okay. A slit here. Just one slit here, like this way. So if there's no slit, what happens? Light will travel straight way now. Okay. But there is a slit here. Okay. So light will travel like this way, and here after that, okay, what we do, we keep another lens here. That lens we write as L2. Okay. That is second lens here. Okay. Let's mark this lens as say L2. This is second lens here. Okay. So this light ray goes to optic center in both lenses. There is no deviation. It goes here. Let's keep a screen here. Okay. This is a screen. Okay. Now what we do is let's name this point as O. Okay. Then from here light goes like this way, we know. Then after this point, okay, actually light must go straight only. Light must go straight, but there is some deviation here, some bending will happen. Okay, because there's a diffraction happening here. So this light ray will diffract on top like this way. This light ray at this point will diffract here. We'll draw a line here. Okay. So from this point will diffract. Then the third light ray will diffract here. So that angle, if you see, that angle we marked as theta. This angle is also is theta, and this is third angle that is also theta. Okay. All three rays bend at the same angle. Now the second lens, what does it do? It will focus all the light rays to one point on the screen. So this second lens here, it focuses all the light rays to a single point on the screen. Let's name this point as P. Okay. So the light rays are all focused at a single point here. Now what we do, we'll name this point here. Okay, this point you name it as A. This point you name it as C, and this point you name it as B. Okay, A, B, this middle point is C. Now what we do is, from A, you draw perpendicular to this line. Okay, draw perpendicular like this way. So this is a right angle here. This also is a right angle. Let's name this point here as N. So we get a triangle ACN. Okay. So and this angle here, this angle also is theta. Okay. This angle is theta. This angle also will be theta. Okay. So we see that light rays parallel now. Parallel means what is that we get a plane wavefront here. So that is a plane wavefront. Okay. So a plane wavefront is formed here. And the distance between the slit, okay, this is a single slit here, and the screen, the distance you mark it as capital D. Okay. Now our aim is that point P, okay, this point P must be either, right here point P, this side here, point P either must be bright or dark. Okay. So brightness happens during constructive interference and darkness happens during destructive interference. Let's see this now. So this is a slit here. Okay. The slit has a width. Okay. The width of the slit we write as small a. The width of the slit we write as small a. That's the width of the slit. Okay. Now we seen that we divide the slit into two parts here. There is even number of parts. If we divide into even number of parts, we get destructive interference. And if we divide the slit into odd number of parts, we get constructive interference. Let me write it down. So if we divide the slit into even number of parts, okay, that means 2, 4, 6, 8. Okay, we get destructive interference. We get destructive interference. Okay, that means we'll get a dark spot here. Then, if you divide this into odd number of parts, the slit, okay, if you divide into odd number of parts, we get constructive interference. That means this point P will be bright. So we'll get here constructive interference. Okay. So this is one thing. Now let's take one thing. This point P should be bright here, or it must be dark first. We'll take condition for first minimum here. Okay. This point P should be dark. We'll see the condition for first minimum. So condition for first minimum. the condition for the first minimum. Okay. Let's see the condition for the first minimum. Let me take a chalk here. Okay, so I'll take this portion here. Okay, this portion I'll take here. We have slit like this way. Okay, and then it's like this. We have triangle formed here like this way. And then this is the horizontal lines. Okay, this is another horizontal line. This is another horizontal line corresponding to these three lines. Now you see this point is A. Okay, this point is C. This point is B. Okay, and the angle here, if you see, this angle is theta. And then I told you we will mark this as N. Okay, like this we have here. Now I'll take this triangle ACN. Right angle is formed here. Okay, so I'll draw a triangle here. That is, this triangle is ACN. Okay, if you see that AB. Okay, AB, if you see that its full angle, full distance will be, that full distance is A, and half of that will be A by 2. Okay, this is A by 2 here. So this region that's AC. AC is A by 2. Our aim is to find what is CN. This angle we marked as theta. Okay, to find that what we do, we take sine theta. Okay, so sine theta is equal to, we know, opposite side by hypotenuse. Okay, opposite side by hypotenuse here. So opposite to this theta is Cn. So Cn by hypotenuse is A by 2. This is sine theta. Cross multiply A by 2 here. So get here A by 2 sine theta is equal to Cn. Okay, this will be using it in the coming expressions here. Let me erase this board here. That's it. Okay, I erase the board here. So now let's see these 2 points A and C that we say is corresponding points. Okay. Points A and C are said to be corresponding points. Okay. Then next what we do is we must see the path difference here. You can see between first and second ray. Okay, the path difference is Cn. Okay. So path difference, that is Cn. Path difference comes to be Cn. Okay. And then we see that path difference usually we write as del. There is symbol for path difference. Del is equal to, we saw that now, Cn, that is A by 2 then sine theta. That is the path difference here. Now our aim is that what's the condition for first minimum. Okay, so let's see the condition for first minimum. The condition here will be, you see that this A by 2 sine theta must, and then when we must know that del is equal to lambda by 2. So we can equate these two, del and del here. Okay, let me erase this down. So we get here A by 2 sine theta is equal to lambda by 2. So 2 and 2 cancel. So we get here A sine theta is equal to lambda. Okay. So this is a condition for first minimum. That means at this point it must be dark. Okay, that's the thing here. Let me erase the board now. Now let us continue this. Let's see the condition for the point P to be the second minimum. Okay, so it must be the second dark fringe. Let's see that now how to do. So I said now we have to divide this slit into even number of parts here. Okay, first we divide in 2 parts here. You can see the first picture, we have 2 parts here. Now we'll divide into 4 parts in C. That's the slit here, that is this part. Okay, we're going to divide into 4 parts here. So like this way. So 1, 2, 3 and 4. So 1, 2, 3, 4. Okay, now this portion, you see, this full thing is A. From here to here, that length is A. We divide into 4 parts. So this region, okay, will be A by 4. This length will be A by 4. Okay, so let's see the path difference now. Okay, the path difference in this case, that is del is equal to, we have here now A by 4 sine theta. Okay, first we had A by 2 sine theta, now we are having A by 4 sine theta. Okay, and let's see the condition here. Okay, condition for this point P to be the second dark fringe. Okay, the condition is it should be equal to lambda by 2. Okay, del should be equal to lambda by 2. So del, okay, is equal to lambda by 2. So we can equate these two. So that is A by 4 sine theta is equal to lambda by 2. So now we can cancel easily. 2 ones are 2, 2 twos are 4, and bring the 2 upwards here. So what we get is A sine theta is equal to 2 lambda. So this is the condition for the point P to be the second dark fringe. Okay, so similarly we'll see for the third dark fringe. Okay, let me erase it now. Okay. So condition of point P to be the third minimum. So point P should be the third minimum here. Third minimum. So that's very simple. So we now divide 4 parts. Now let's divide into still more parts here. 6 parts will do. Okay. So this slit here, the slit AB. Okay. We're going to divide into 6 parts here. Let's see this now how to do. Okay. So 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6 parts here. So this distance will be now, it will be A by 6. Okay. And now let's see the path difference in this case here again. The same method only. So let's see the path difference. Path difference is del is equal to, in this case it will be A by 6 here. Okay. A by 6 and then sine theta. Same method only thing we just change the number here. Okay. And let's see the condition here. What is the condition for? It should be minimum. Okay, third minimum. Condition should be del is equal to lambda by 2. Same method only. Okay, so equate that. So A by 6 sine theta is equal to lambda by 2. Okay, excuse me. So 2 ones are 2, 2 threes are 6. Okay, so cross multiply here. So it here A sine theta is equal to 3 times lambda. Okay, so this is the condition for the point P to be the third minimum. Okay, so now let's see. Generally we write here. Suppose we want to be nth minimum. Point P should be nth minimum. Let's see how to do that now. Let me erase this. Note down. Okay, I'll erase it now. So condition of point P to be the fourth minimum here, or the nth minimum in this case. We'll go to nth. It can be any number. Okay. So let me erase it out. Okay. So we divide into first we divide into 6 parts now. Now let's divide this full thing into n number of parts. Okay. We're going to divide this into n number of parts here. So we have here n number of parts here, and then okay, what we're going to do is we're going to divide into equal, that is even number of parts. So we don't just write n times, we write as 2n. Okay. 2n number of parts here. So let's see how to write the same method only. So we'll equate the last step. Okay, I'll take the last step only. That is A by, in this case will be 2n sine theta is equal to lambda by 2. Okay. So in this case 2 and 2 will cancel. N goes upwards. So what we get here is A sine theta is equal to n times lambda. So this is the condition for the point P to be the nth minimum. Okay. So A sine theta is equal to n lambda. This is equal to sine. Okay. So next we'll see what are the conditions for point P to be the maximum. That we'll see next. Let me erase the board now. Okay. Now let's see what are the conditions for maxima. That means point P should be a maximum, that is a bright spot here. Let's see the condition here. So first we'll take the condition for point P to be the first maximum. Okay. So condition for the first maximum. First maxima I can write here. First maxima. Okay, the first maximum, we'll see how to get this. So I said now we divide into even number of parts. Okay, now we're going to divide into odd number of parts. Okay, like 1, 3, 5, 7. So one slit we can't do. So let's take 3 here. Okay, so this is slit here. Okay, now we divide into odd number of parts. There's 3 parts here. Okay, so like this way. So 1, 2 and 3. So it's an odd number. Okay, so we divide into odd number of parts. So let's see the condition here. Okay, so that will be as similar. We get here A by, in this case that will be 3. Okay, A by 3 sine theta is equal to lambda by 2. Okay, so what we do, we just cross multiply this 3 upwards here. So we get here A sine theta is equal to 3 times lambda by 2. So this is a condition for point P to be the first maxima. Okay, point P, this point P should be the first maxima. It should be the first bright spot. Okay. Next what we do is similarly, let's see condition for second maxima. Okay, same method only. We're going to change the numbers here. Okay. So you first write this down. Okay. Now condition for point P to be the second maxima. So first we did for 3 parts here. We divide this thing into 3 parts. Now we'll divide into same. Next is 5. After 3 we have 5. Okay, that's odd number. So this equation will change. Let's see how we do it. So 5 parts. 1, 2, 3, 4 and 5. So 1, 2, 3, 4 and 5. We divide into 5 parts here. In this equation what we do, instead of 3 what we do is just we change it as 5. Okay, we saw that now. Just change, instead of 3 we change it as 5 and 5 goes upwards, so this will become as 5 lambda by 2. Okay, so a sin theta is equal to 5 lambda by 2. So this is the condition for second maximum. That means point P should be the second maximum. That is first maximum will be here, second maximum will be here. Okay, that's the condition here. Next we'll see condition for point P to be the third maxima. Okay, let me erase it out. Okay. Note this down. Okay, you pause it and write down. Now I'll write for the condition for third maxima. What's condition for the third maxima? So after 5 we have 7. Okay, so numbers we must change here, and the number of slit also you change. Okay, so every time is draw rabbit and write one more time. So 7 parts here. 2, 3, 4, 5, 6 and 7. 1, 2, 3, 4, 5, 6 and then 7. 7 parts here. So in this equation you write as 7 here. Okay, 7. And then what we do is cross multiply 7 upwards here. So instead of writing 5 here, we get the equation as 7 lambda by 2. So a sin theta is equal to 7 lambda by 2. So this is the condition for the third maxima. Okay, next we'll see what condition can we get for the nth maxima. Okay, it can be any number of, it can be 7, then 9, 11, it will go. We'll take nth number. Okay, so shall I rub this now? Okay, rub it now. So condition for nth maxima. Okay, so for condition for nth maxima means it should be odd number. Okay, so n, if you write simply as n means we write n as 1, 2, 3, 4. Okay, but we have even numbers and odd numbers in it. Okay, so you must change the even number also into odd number. So if you write 2n, 2n means what? If you divide this slit in 2 in number of parts. Okay, let me rub this number here first. Okay, then we'll write now 2n. So n is equal to 1 means 2 into 1 will be 2 only. It will be an even number. To make it odd, we just add 1 here. So 2n plus 1. Okay, we divide this number of slits into 2n plus 1 number of parts here. Okay, so we get 2n plus 1 number of parts here. Okay, so same way in this equation, in the denominator we write as 2n plus 1. Okay, 2n plus 1. So we had 1, 3, 5, 7. Now you're writing here 2n plus 1. Okay, so after it cross multiplies, it goes aside. So we get here 2n plus 1 into lambda by 2. So this is the condition for nth maxima. Okay, that means it should be you can take any number of values here for n. So n can be equal to 1, 2, 3, like so it goes on and on. Okay, you can take any number, it will become an odd number. See, 2 into 1 is 2, 2 plus 1 is 3. Okay, 2 times if you use 2 to 4, 4 plus 1 is 5. So this is the condition for nth maxima. Then one more thing you can see here. I'll write this side. One thing to note. Okay, I'll write here a note. Okay, we wrote here sin theta. Okay, the sin theta is there, and then we saw this distance from O to P. This distance was y. Okay, y d. So let's take this theta here. I'll take this triangle here. Okay, I'll take this triangle like this way. The triangle is like this. Okay, so this side we have here y. This angle is theta, and this distance is d here. Now we take sin theta from this. Okay, sin theta means what? Opposite side by adjacent hypotenuse, we know. Okay, opposite side by hypotenuse. We can take sin theta, or you can take also take tan theta now. Okay, for example, we'll take tan theta first. Tan theta is opposite side by the adjacent side. That is y by d. Okay, and then if we take the angle theta is small. Okay, so theta is very small. This angle. Okay, it's very small. So what happens is, instead of writing tan theta, you write as tan theta is approximately equal to sin theta. So wherever sin theta comes, you write as y by d. Okay, so we can write here this tan theta, or you can write sin theta is equal to y by d. Okay, so in this equation we can write as y by d. Okay, and then we can solve sums there. Okay, so this is another method of writing it, that you can note it down last. So this is about the thing here. Diffraction is single slit. Okay, that means we have a single slit here. what happens to diffraction, how we get the colored fringes formed here. Okay. So diffraction means bending of light around an obstacle. Okay. So this is something here, note down. Thank you for watching.